Okay, example 2. A handicap ramp 8 feet in length has a vertical rise of 1.5 feet. Let's just stop there. If I was thinking about a handicap ramp forms a right triangle. If this is my ramp up here, in order to support it, I have to have a right triangle below it. Okay, so let's read what it says one more time. Handicap ramp 8 feet in length. So it's telling me the ramp is 8 foot long. So the ramp is this part right here, the hypotenuse. My right angle is formed over here, lower left again. And it says it has a vertical rise of 1.5 feet. So 1.5 feet is over here on the left. Okay, so it says calculate the horizontal run of the ramp to the nearest tenth. So we're looking at this horizontal distance right here that we do not know. So I'm going to call that x. Nearest tenth, in this case we're talking feet, so the nearest tenth of a foot. And then it says to meet ADA compliance, a ramp must have a ratio of 1 to 12 rise to run. So what that's saying is for every foot vertically that it rises, it has to have 12 feet horizontally to make it safe. Okay, so we'll come back to that in just a little bit. Does this ramp meet ADA compliance standards? If not, what changes would make it ADA compliant? Okay, so first off, I need to solve for x. So you notice that we have a right triangle. So I'm going to use the Pythagorean theorem, like back at the top of your page. Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. So I have 1.5 squared plus my other leg, which is x squared, equals 8 squared. Okay, so take your 1.5 and square it. And you get 2.25, and we'll hang on to the decimals until the end so we don't make a rounding mistake. 8 squared is 64. And then similar to before, because I only have an x squared with no other x's or anything, I can isolate x squared on the left, my numbers on the right, and use the square root property. So if I'm going to get x squared on the left, I have this 2.25 with it that I don't want, so I'm going to subtract it because it's positive. If I do it on the left, I do it on the right. Okay, so my x squared comes down, and 64 minus 2.25 is 61.75. Okay, so once again, my square tells me I'm going to have two answers. To undo my square, I'm going to square root, and don't forget to be in the habit of adding that plus or minus out front. So the square root and the square go away and leave me with x. Since we're talking length, the length of a ramp, I'm not going to take the negative value, but if it was just the problem that you were solving, not as an application, you would want to keep both the positive and negative. But since we're talking length, let's find the square root, 61.75. Round to the nearest tenth, so that's going to be 7 point, since it's 8.5, since 5 and up you round up, it'll be 7.9 feet. Okay, so this horizontal distance is 7.9 feet. Let's go back and look at ADA compliance. So for this particular ramp to meet ADA compliance, if I have 1.5 feet in rise, I have to have 12 feet in run for every foot in rise. So I'm going to take my vertical, 1.5 feet high, and I'm going to multiply that by 12. And if this ramp is going to be ADA compliant, whatever I get when I multiply that by 12 should be my horizontal distance to make it safe. If this horizontal distance that I calculated is less than whatever I get here, then this ramp is unsafe. Okay, so 1.5 times 12 gives me 18 feet. Okay, so to be ADA compliant, we need 18 feet horizontally, and ours does not even come close. So we have 7.9. So that means this is a pretty steep ramp, okay, up here. All right, then it says, if it does not meet ADA compliance, back up here in the problem, what changes would make it ADA compliant? Well, we'll just say it does not meet it. Scoot this up. It does not meet ADA compliance. What changes? We would need to say something about the run or the horizontal run would need to be at least 18 feet. Thus, extending the length of the ramp so that it's not so steep. Because the longer the ramp is, the less slope it has, if you think of it like slope.